Hello, Bhavna. Am I audible?
Yes, sir.
Okay, I'm sharing my board. Bhavna, do we had a discussion of velocity yesterday?
Yes.
We had it. Discussion of velocity. We will do so. Let's see. Okay. So, what is velocity? Velocity is basically velocity. So, velocity is nothing but your displacement. Right? What is the displacement per unit time? So, you can simply say that ds divided by dt. Now, Bhavna, you know that we are like actually doing it on the coordinate form, right? So your displacement can be in a format like x of I cap plus y of j cap plus k z of k, right? These can be some form. So your velocity actually, what it can be written as? It can be written as dx by dt in I direction, okay, plus dy by dt in j direction plus dz by dt dz by dt in k direction. This can be used for velocity. Now, if you figure out it, I can individually write dx by dt dy by dt is dz by dt as velocity in particular direction, right? I can simply say that this net velocity is nothing but velocity in x direction, your I cap, plus velocity in y direction, j cap, plus velocity in I think z direction, k cap. So you can see these are some vector representation of your velocity. Okay. Here, instead of this delta, you can also write this. This can also be written as delta x y delta 2 plus delta y by delta t plus delta z by delta t. All of them are in respective direction. This is in K, J, and this will be in I. So this is what your velocity can be looked at. Just let me know if you are clear with all these things. Hello, Ketna. Yeah, Bhavna, is it fine? Like till now, any doubt?
No, sir.
No, right? Okay. So this is a very small discussion about the velocity. Okay, it's a kind of mathematical representation you can have. Now, as we have studied it so far, we can simply say that this is nothing but a rate of change of velocity you have given away. If I ask you, Bhavna, in this coordinate system, what is the magnitude of velocity? So, like, if I ask you, if I just give you this velocity, uh, yeah, this one, and if I ask you what is the magnitude, so you can simply say the magnitude will come out as this magnitude, right? What is the magnitude, Bhavna?
Under root of
Exactly, under root, right? So, under root of Vx square plus V of y square plus V of z square. Okay? This is our magnitude, right? Let's come up with three more different kind of velocity. One is Bhavna uniform velocity. Okay? I can say a particle is moving with a uniform velocity if it is covering equal interval of equal displacement in equal time. Okay? So, yes. So something we have called uniform velocity. Okay? What does this mean, uniform velocity? Equal distance and
displacement in equal intervals of time.
yeah, exactly. Equal displacement in equal interval of time, right? Equal, okay, let's write displacement in equal interval of time. Okay. Same you can say for the speed also. Okay, so I don't think I have to take the speed part in a different way. Okay, along with velocity, I will try to wrap the speed part also.
Okay, sir.
Equal number, yeah, that's fine. Done. Okay, so in case of speed, you just have to replace this displacement with the distance. Okay, that's the thing. All right. Now we have a variable speed. What is variable speed? When it is covering equal displacement in unequal interval of time, that is a very simple. If you know one is for equal, if I'm saying that is uniform, so I can say this one is a non-uniform. Okay. What is average velocity? Why we come up with the term average velocity? Assume Bhavna, a person is there and he have traveled some particular distance, maybe from here. This is the distance he have traveled. Okay, and let's say in this whole journey he covered from here to here with some velocity v1. Okay, after this from here to here he covered some velocity v2 with v2, like he is covering these distances with these particular velocity. Okay, this he covered with v3 and so on. Okay, so on so forth, so on. You will be reaching here and last he has covered with Yeah. Now, if you suddenly, let's say, reach at the destination and someone meet some person he met, and he's asking what was your velocity when you were coming towards me. So which velocity he's going to choose? What he will say that I covered, like I came with this much velocity, with this velocity, or which velocity he will represent himself. Like what is the velocity he is going to represent his distance, right? So again, the problem is that he don't have single velocity, right? He had multiple velocity is in
Yeah.
whole path. So there's a, like what he can do is he can simply tell the average. What is the average velocity he have moved? So a very one idea for the average velocity is, I'll remove this. Yeah, average velocity is nothing but, it is nothing but total displacement divided by total time. Total time. This is one way. Okay. This is the average velocity part. Clear? That is the thing. In another way, you can say that, yeah, that's fine actually. So you can write this as, maybe in case if you have moved from here to here for a one vector, so I can say this is R1. After that, you move to this point. Like let's say this was your initial point R1. Okay, and this is your final point. So you can simply say R2. And you know the displacement vector in between them. So you can simply say this is the displacement vector. So maybe R2 minus R1 vector you will be having here. So you can, what you can say here, this is R1. So you can simply write this as R2 minus R1 divided by T2 minus T1. Okay, this is the thing. All right. So that is the thing about the average velocity. In case of speed, you don't have to write this part. Okay. In case of average speed, what happens is that average speed is nothing but the total distance. Okay, not displacement, total distance, like exact distance covered upon time. So total distance upon total time. In case of straight line motion, if a person is not changing his direction, like in straight line option, only two directions are possible. You can say in a frontward, in a backward. Okay, like you can say x1 minus x, either y and minus y, z and minus z. Okay, so if either of the direction has been chosen, and if I'm saying that person is moving with the uniform velocity, that it's a very evident that the person is never going to change its direction. Okay, it means in those cases, your displacement and distance is going to be the same. Okay, velocity and speed is going to be the same. So yeah, that's a thing. When we say about speed, again a simple idea. Speed is nothing but distance upon time. Uniform speed, if he is covering s- an amount of speed, like an amount of distance in equal interval of time. So that makes a sense. About the variable speed, a person is changing his speed in the journey, whole journey he's changing speed. Average speed, the total speed divided total distance about the total time. That's it. Okay. So that is then. Let's talk about a uniform motion. Okay. So when I say you are having a uniform motion, what are the feature of those uniform motion? What's some feature of the uniform motion? Okay, I'll just explain it. I want, right? Features of a uniform motion basically. Uniform motion is a straight line motion, okay, with a constant velocity. You can't have a other kind of motion which is uniform. If it is there, we will particularly represent it with a shape. For example, sometimes we call uniform circular motion. Although the motion is not a uniform because the particle has acceleration. All the particles who are in the circle, moving in the circle, have acceleration, have a changing velocity. And the moment velocity is changing, we can call it as a non-uniform motion. But still, we are saying that as a uniform motion because that is particularly for the circle. Okay. In case of circle, we are saying that particle is not changing the speed. But the, but the problem is, if you just see the circle, how he is moving. He's moving like this. This is the curve, right? So you can say particle was here. Had a velocity this much, v1. Okay. Here he will go. So here velocity will be the v2. Why I'm saying the different v2? Because even though their magnitude of velocity or the speed is still the same, speed and magnitude of the velocity are still the same. But the problem is he is moving in this direction with 5 in this direction. Here he is moving 5 meter per second with this direction. Okay, so this direction parameter is changing is the main cause of making it a non-uniform motion. Okay, because it is providing an acceleration. You can also say that when you are having a uniform motion in a straight line, okay, without changing its velocity, in that case, the magnitude, yeah, the magnitude of the velocity and the distance are same also. Okay, because magnitude does only represent the exact value, right? So I can simply say if it has not changed its direction or something in the whole journey, you can say in that case the speed and the velocity are same on the magnitude part, okay? On the note of magnitude. Okay, so Bhavna, if I just represent the dimension of the velocity, so what I'm supposed to get? Velocity dimension. So it will be nothing but m. Mass is not there, right? Because if you just write the formula, that is v equals to x by t, okay, general, because we just had to get the dimension, so we
LT
are not,
minus 1.
yeah, so we can simply say L1 t minus 1, okay, this is the dimension. Fine. Okay, so Bhavna, let's solve one problem and then after that move to the next part. Bhavna, I had shared you my vector sheet worksheet. Had you solved those problems from that worksheet?
So I started doing that. I didn't complete that yet.
Okay, no problem. But actually, what happened, Bhavna, in that sheet you had a lot of problems. Okay, so okay, how you're solving the problem? Like you are going line by line, each problem one by one.
Yes, sir.
I will say don't go with that because it has too many problems to solve. Okay, so what you can simply do is start solving from the top. If you see, okay, this is a problem. I have not solved any kind of these kind any problem from these kind of things. Just solve it. Okay, move to the next. If you see it is just similar to that the previous one, skip it. If you see this is very simple, like you have maybe done in the previous part as a sub part or something, again skip it. Okay, so only do the unique questions, at least unique of two problems. Okay, not more than that,
Okay, sir.
because
Okay.
it has like if you just count all the problems, maybe 60 70 problems are there which I could remember. Okay, so that's the case.
Okay, sir.
Okay, so wrap that vector part because you have to move to the this you have to start for this one. Okay, so whenever you are done with the vector problems, just let me know. I will give you the worksheet for these things. Okay, problems are little bit in the like main side or you can say advanced side. Okay, that's not the issue, but you should be able to solve those problems. Okay? And try to solve in a lesser time. Okay, don't try like don't take too much time, okay, in solving the problem, because you have to make a practice such that you are able to solve the problem within a very small period of time, okay, within a very less time. Okay, This should be your task.
Okay.
Okay, so Bhavna, one problem I'm giving. A car is there which has traveled first third of the displacement at a speed of 10 kilometer per hour. Okay, I'm not writing a problem. It's a long thing, and my pen is not working that way. But, yeah. A car has traveled first third of the distance at speed 10 kilometer per hour. Second third at the 20 kilometer per hour, and last third at a 60 kilometer per hour. So you have to determine what is the average speed of the car. Understood?
Okay.
Should I explain rephrase the question again?
Yes.
Okay. A car is there. Okay. Wait, I'll just mark it in this way. It will help you. Look, this is the distance total which you had to cover. Okay. What the car did? Car covered one third, basically d by 3 distance. This car covered with 10 kilometer. Another d by 3 it covered with 20 kilometer per hour, basically. Okay. Yeah. One more thing. We have not discussed a lot part in the what I can say the units, but you have to take care of the units carefully. Okay. And the last third will be the 60 kilometer. So you can see d by 3, d by 3, what you are left with last d by 3. So what is it? 60 kilometer per hour. And the total distance is given as d itself. Okay. Per hour. That's the thing. I have not given you the time. I have just given you the velocities. Okay. So you have to solve it by yourself. Take 2 to 3 minutes. This is the last problem from today's class. I'll give you one more problem as a homework part. Okay, so you can start solving this. I'll write the next problem as homework. Okay,
Okay.
till then. Okay, I'll write that in the text format. Okay, so
So here we have to find the distance.
no, no, you have to calculate in this problem you have to calculate average velocity.
Oh,
Okay, I'll calculate average speed. Okay, because it's just a straight line motion, so the both are going to be the same. Okay?
So is the first one 18?
Yeah, the first one is 18. Okay. All right, fine. So this is a problem. I'll take a next class just now. So I want to complete this problem. Like this problem. I'll just give this as a homework. Right? This problem which I'm writing. Okay. So any doubt you have? Till here? Any doubt till here? Any topic
No,
from
sir.
previous or this chapter or something?
No, sir.
So yeah, like if you don't have that, you can exit the session. In this problem, what you have to calculate is calculate average speed. Okay, just read the problem once.
Okay, sir.
Let me know if any word is there which you are not getting to understand. Figure how I can actually give you, but I think we need this figure also. Figure is not a complicated. If you read just a kind of simulation, just read out, make the figure, along with it, you will get it. So Bhavna, this is the problem. If you don't have any doubt and you can read the problem properly, so we can end the session by that. I'll share this sheet with you. Okay,
Okay,
and
sir.
you complete with the vector sheet. After that, I will share you the sheet of this. Okay,
Okay, sir.
so we are going to begin.